identify and research on otters, on impacts of climate change on otters. Lead to our website. Can you see the screen, the slides? That's fine? Okay, good. So thank you, Simon, for the introduction, which I can skip anyway. I just want to again thank the Otter Youth Circle for organizing this webinar series, which I think will really inspire many of our members and Otter friends to join the wonderful
hey, Anna,
world
sorry.
of Otter.
We can see your presenter mode. Could you try share your other screen?
So you don't see the screen?
We can see your the presenter mode, so I think your second
I need
screen.
help. Is that fine now?
That's the same, I'm afraid. Sorry. Is there another option?
Checking. Maybe. Mm-hmm. Can you see it?
Yeah,
That's fine.
Sorry.
So, thank you to the young member. So sorry. Let's go it again. So thank you to the Otter Youth Circle, but I will skip all in my thank you to all. So this is a brief outline of the webinar. So I will first briefly introduce what is climate change, then how this climate change impacts on species, but also how we can assess the vulnerability of species to climate change, how we did it, an assessment for otters, but again, and then how today the climate change forecasted impact in the future is part of both the guidelines for the red list and the green status assessment, and then how mitigation, which means how we can reduce the climate change, and adaptation, which indicate how we can cope with climate change that cannot be avoided. And finally, the future challenges, especially related to otter research for climate change, what we still need to research and study and understand about these impacts. So climate change was firstly defined by the IPCC, which is the Intergovernmental Panel for Climate Change, which was established in 1988 by the World Meteorological Organization and the United Nations Environmental Programme to provide policymakers with regular assessment of the scientific basis of climate change, its impact, and future options for mitigation and adaptation. So in this context, the climate change has been defined in 2013 as a change in the state of the climate that can be identified by changes in the mean and or the variability of its properties, and that persists for an extended period, which is typically decades or longer. So, but why we have climate change? So climate change has been linked to the increased concentration of atmospheric greenhouse gases, mainly carbon dioxide, which create an energy imbalance at the top of the atmosphere, in the sense that the greenhouse gases trap the sun's heat in the atmosphere and do not allow the radiation to be reflected outside, means the heat, the infrared radiation to be reflected outside the atmosphere. So it works, like blankets that cover the body when we sleep by keeping the heat of the body. So the annual greenhouse gas index is a measure of the capacity of the atmosphere to trap the heat as a result of the presence of long-lived greenhouse gases. So, as you can see here, the majority, the main component of the greenhouse gases is carbon dioxide and methane. Both have a mainly anthropogenic source. So, and here you can see how the concentration of carbon dioxide in the atmosphere is linked to the average mean temperature change since 1890. So, what is important to consider is the trend. So if there are many meteorological research groups around the world that are projecting future climate based on the general circulation models, which are computationally intensive mathematical models that simulate the atmosphere and the ocean processes, including sea ice and land surface components. So each model is run multiple times to accommodate for uncertainties, both in the natural components of climate, but also uncertainties in the anthropogenic variables, including future greenhouse gas emissions. So these plausible scenarios, climate change scenarios, are expressed in terms of representative concentration pathways. Here you can see the acronym RCP, going from the more, can you see the arrow?
No.
Anyway, from the lower blue line, which is the more optimistic scenario, which forecasts a lowering in the emission of this of carbon dioxide, essentially, in the next 500 years, or the worst scenario, which is RCP 8.5, which is accounting for an increasing emission of greenhouse gases in the future. So, and these RCP are not expressed in terms of temperature, but in terms of radiating force. So in terms of watt by square meter. Thank you. So, and in the other graph here, you can see how the temperature of the Earth, mean average temperature of the Earth, are expected to change in relation to this RCP, so concentration, so to these represented concentration pathways. So, climate change can impact species in many different ways. One group of impacts are direct. These are, for example, physiological stress, disease susceptibility, or changes in behavior, phenology, or reproduction timing. But we have also indirect impacts, such as those related with habitat shifting, loss, fragmentation. And what is driving also the habitat change for other species means changes in the interactions with other species, like prey, predators, competitors, parasites, or hosts. So we already have evidence of this kind of impact on species. Many of you know the coral bleaching. Coral bleaching is a direct impact and causing a physiological stress, because corals expel the algae, the zooxanthellae algae that produce when the temperature raises, when the water becomes too warm, they expel toxic compounds. So for this reason, the corals will expel these algae and they turn completely white. Bleached corals continue to live, but they are more vulnerable to disease and starvation. So if the exposure to these conditions will last too long, the corals will die. And we have already observed 4 main events that affected corals at a global scale at percentage that goes from 20% to 54%. And 54% was the last global coral bleaching event that was observed in April 2024. So we have another quite known phenomenon, which is the spreading of the Batrachochytrium dendrobatitis, which is a fungus that affects the skin of many different species of amphibian worldwide, and it's spreading and causing the decline or extinction of amphibians at global scale. That is because the fungus cause the thickening of the skin and promptly leads to the amphibians are not able to breathe anymore, as the skin is a respiratory organ for amphibians. And the fungus is expanding at also elevational range, and it is known to have reached up to 5,000 meters above the sea level, has been observed. So as for disease susceptibility, we have an example for otters. This comes from the group of Elizabeth Chadwick at Cardiff University. So Sarah Duplessis, she's here, she's part of this research group working years on analyzing otter carcasses to detect trends also in this phenomena of disease susceptibility. So they found that the probability of infection of 2 trematode biliary flukes that infect otter and mink was positively associated with warm, long-term average temperature in UK. So they forecasted an increase of infection under global warming. We have another predicted change in behavior for otters. This is a population of the North American river otters living in coastal Alaska, where the males, only the males, they forage cooperatively on schooling fish, while solitary otters, which are usually females, they feed on intertidal demersal fish. Because the abundance of schooling fish, pelagic fish, is predicted to decline with climate change, the number of social groups otters are also expected to decline too. This will lead to a decrease in otter density, but also a change in the way the nutrients are affecting the vegetation on the shore. As the more the otters will become solitary, they tend to mark their territory to defend the forage hunting ground. So has been predicted an increase of 25% of nitrogen on the land. Thus, that will likely modify the nutrient deposition, the productivity and diversity of the terrestrial landscape and vegetation. So it is not only related to otters. Another very famous example of indirect effect of climate change is habitat loss by the polar bear, and the US Geological Survey estimated that the future reduction in sea ice in the Arctic could result in a loss of 2/3 of the world's polar bear population within 50 years. So this is another example of indirect impact and range shift, but affecting multiple species. This is the results of observation by the US Global Change Research Program, that the range of marine species in US waters has shifted northward as water have warmed. And at the same time, a shift in timing of plankton blooms was also reported. These are just few examples of different kind of impact. So, but it is very important that we are able to develop an assessment of how the climate will impact species, so to be ready to identify the management options, implement these management options. So for that reason, the IUCN SSC has established I think in 2019, I didn't find in the website, but anyway, it should be very close to this paper published by Wendy Foden, who is the chair of the group. Just to produce guidelines and address how we can assess the vulnerability of species and take actions. So what is climate change vulnerability? Is the extent to which biodiversity will be adversely affected by climate change, and it is a function of the character, the magnitude, and the rate of the climate change to which the species is exposed, but also its intrinsic sensitivity and adaptive capacity. So here is the greatest vulnerability of the species is found at the intersection of these three components of climate change vulnerability, which are exposure, which means habitat loss, fragmentation, and shifting, but also the adaptive capacity of this, a low adaptive capacity, which is related to internal factor, physiology, for example, and to sensitivity, which means how, sensitivity is how the physiology or other life traits are directly affected by climate change, but also how the species could respond, can adapt the physiology to the new conditions. So in some way also how large and extended is the niche of the species. So which are the questions we should answer when we assess the climate change impact? Is which species are more vulnerable? How much they are vulnerable? Why they are vulnerable? Which are the driver of this vulnerability? And where they are vulnerable and when they will become vulnerable. So looking at otters, as many of you know, we have now 14 species of otters because a new species was just described in 2023. And of these, 12 are freshwater species, and then we have 2 marine and sea otters, so marine species. So as many top predators, otters have been persecuted for conflicts with fish activities. They've been heavily hunted for their highly valuable fur, and their habitat has been highly impacted by human activities such as water pollution, water extraction, drainage, destruction of riparian vegetation. So Following these multiple threats and pressures, otters are among the most threatened mammal guild, and all species but the North American river otter are listed from near threatened to endangered at global scale. So in this context, climate change can add another threat that could seriously impact some of the species. And this is very important for us to identify which are the priorities in terms of species, areas, and identify the proper strategy to mitigate these impacts. So in 2018, a PhD working in my group, we did produce a global vulnerability index, which was based to both range exposure and sensitivity. All this work was based and started from spatial distribution modeling. So we considered the range exposure, external factors, including changes in the range extent, changes in the fragmentation of the current and future projected of the range, the protected area coverage, and the changes in the human footprint coverage. This is an index, the human footprint, that allows to summarize the human disturbance on a spatial scale and project it in the future. So all these number and sensitivity was based on two components: the niche specialization and the niche marginality. I will show you with an example what this means. So all these numbers were combined in one global index, vulnerability index for otters, which values range from -100 to +100. So from values greater than 0 indicate a positive impact of climate change, and values below the 0 indicate a negative impact. So how we did it? I know this is quite complex, but not too much. We produce a species distribution model starting from species occurrence data and 6 climatic variables that were highly related to the otters' biology and ecology. And these were combined with multiple modeling techniques to provide a potential distribution of current potential distribution of the species based on its climatic niche. This current situation was both used to identify which, for example, which of the climatic variables was more important in the model. So you see the more important are from red to orange, for example, but also to identify how narrow was the range of suitable values for that species. So this means specialization and marginality, how this suitability, climatic suitability, was located toward the Q of the background values. But this was also used, the results were used to project where we will find the same conditions under the RCP scenarios. We use the worst one, 8.5, and the best one, more optimistic one, 2.5, at 2 time period, 2050 and 2070. And we then projected where we will find this condition in the future. As you see, this is the Congo clawless otter, so that what is all the areas suitable today will be highly reduced in 2050. So we combined this evidence, the change between this and this, in the extrinsic range exposure. We added the degree of fragmentation of this area, the total area, but also how much of this area will be protected in the future, will fell into protected areas, and how, on the other side, they will be impacted by the human footprint. This means where the suitable climatic niche, for example, if it will overlap with a huge, big city that likely will be not suitable for the otters. So these are the results of these future scenarios. And what you have to see is the red bars, which are related. There are 4 because there are 2 scenarios for 2 time periods. So you always find 4 bars for each color. But the red indicate the extent, the global vulnerability index of this species, and all the other colors are indicated which components are contributed to the negative impact, or they're counter balancing the negative impact of some factors. So as you see, all the species will likely be negatively impacted by climate change following this modeling, but the neotropical river otter, which is the only species that have a positive value. I will show some examples if, let's see the time, easy here. But we can go maybe during the discussion. I can show you some examples on how to read these results. This is what I said, the Congo clawless otter, which was the species, the most concerning species, as it has the highest negative global vulnerability index from 40 to minus 40, minus 49. And as you see here, both components of vulnerability are contributing to the index. So they will be highly impacted, the exposure. So the range will be highly reduced, highly fragmented. There will be a positive protected area coverage. This means that the residual area will be mainly covered by, they will fall within protected areas, but they are also highly sensitive. This means the climatic niche is marginal. You can see here, for example, and narrow. So this species, this is concerning, and you already can see that this species is classified as near threatened. So near threatened, facing this very worse and concerning future, might be, I think we have to reevaluate, but today we know how to do it, so I will show you later on. So this is another Aeonyx species. This is the Asian small-clawed otters. Again, this is one of the most impacted in Southeast Asia, and again, to this global negative vulnerability index is contributing both the exposure and the sensitivity. So both components of the vulnerability are concerning. I will show you another example. So here, for example, is the giant otter projection, where, as you can see, there will be, I mean, a negative impact of climate change in terms of climatic niche, but the component that will contribute the most is not the range exposure. As you can see here, in fact, the net balance between the area that will be lost in red and the areas that will be gained in red is in favor of an extension of suitable habitat. But the species is highly sensitive to climate change, so will not be able to cope in the area where it lives with any, there will be an impact on the species. We will see this afterwards. So the same stands for example, for Lutra sumatrana, and here the concern is higher. It's the same pattern we saw for the giant otter, but the problem is that this species has a a very small range, and it is also now what we don't know much about ultrasumatran. We need to know more. So I will go through now this. For example, other examples we have, for example, low impact. You can see there is a very small negative impact, general one, on the Eurasian otter, and mainly related to its sensitivity, its narrow niche and marginality. Whereas the next balance between areas that will be lost and gained is in favor of the in favor of the habitat that will be gained. But don't forget that the area that will be lost are different. They fell in different countries and areas with respect to where the species will gain habitats. This means that, for example, in some country, the otters, the Eurasian otter, can go extinct according to the impact of climate, of global warming. The same stands for the North American river otter, but this is expected that these two species are like ecological vicariant, so they're very similar. So they respond likely to this. It's very similar, the pattern, because they're very similar as species and they live in the same ecosystem. This is the only species for which we found a positive impact of climate change. So the balance between the niche sensitivity and marginality and the exposure was in favor of the species. But again, we don't know, because now we have this area, which is the range of the new species. So both species should be reassessed again, considering the species splitting. So this is something we added to the evaluation in the global conservation strategy for otter by adding some other information to identify a global concern, the priority of species we should focus for climate change impacts, by adding some other factors or adaptability, like diet specialization, habitat specialization, biotic interactions, which means with how many species they have an overlapping range, and the range extension, and the red list category. So by considering all these factors, we identified 6 species of high concern for the global warming. This is we tried also to identify priority areas, concerning areas for global warming. This is a general map summarizing the results of habitat gain, lost, and stable for all the freshwater species at 2070 in the worst scenario 8.5. So we know that in some area, maybe we will lose most of otters, other species. So now, do I have some time? I'm okay.
There's still time, Anna. You're welcome to keep going.
Okay, thank you. So recently, this was, I think, published in 2022 or 23, the new IUCN SSC guideline for assessing, that were published by the IUCN, the guidelines for assessing the species vulnerability to climate change, which also include where you have to account for this impact in the red list assessment. This is an example which relates to the modeling I have just been shown. I just showed. So, for example, the criterion A3, you know that the red list assessment has 5 criteria. A is related to population size, so it's numbers. But This population size in the next assessment should be based on suitable habitat at 3 time points: the current, a year as close as possible to the assessment year, in 10 years or 3 generations after the current, and in the future, which should be no more than 100 years after. So, but you should be warned that in this, we have 2 other issues in this new assessment. First, we have to convert the amount, the availability of suitable habitat into population size. And for example, for otters, we often lack this information, which usually are derived from non-invasive genetic sampling, for example. So for Eurasian otter, we have quite a good estimate of how many otters we have per unit area. This is one thing. The other thing, the other issue is that the assessments that rely on climate data alone are prone to over-predict areas of suitable habitat because climate may be suitable, but the land cover may be unsuitable. This is the habitat specialization, not climate. So land use should be used in combination with future climate projections to create more refined estimates. And this is exactly what we did before the guidelines were published. This is, for example, a projection of how areas will be suitable in 2080. This was done in 2011, so before the modeling of all species across the world. But you can see the difference by including land use combined with climatic variable projection in the future. We will have many areas that will decrease in suitability, whereas if we only look at climate, they likely will remain stable. So a same work was done on Trans-Himalaya by Pushpinder Jamwal, working, he done his PhD and is still here as postdoc and is still listening at the webinar, I hope. He did project in the future, currently and in the future, the habitat and climate, habitat in terms of land use, suitability from current changes to the future. And the future include the projection, because today we know how the land use will change in the future. So I really encourage you to start and run these models, including both climate change and land use change, to produce an estimate that what will happen in the future to the otters living in, for example, in your countries. So why? Doesn't, I don't know why, doesn't, is happening. Can you see the screen yet still?
Yes.
Okay. Oh. Sorry, something happened with the PowerPoint. So I just have to close and be back again. Okay, no, maybe, let's see. Okay, it works. Okay, sorry, I don't know what's happened. Anyway, the same stands for the green status of species. This is a new evaluation that allows to evaluate how far a species is from its fully recovered in its former range, historical range. This means before the decline. So, and this is evaluated both considering the effect and the impact of conservation measures and the counterfactual evaluation without, if we did not take any conservation measure. So, but as you can see here, we did it and it's published, and you can check the assessment for the Eurasian otter, but the Otter Specialist Group is going to complete the assessment for the green status for many other species in the next year. And what you can see that Eurasian otter, is the final evaluation is that this species is largely depleted. This means that we do not expect that the species can fully recover in its historical range. And this is mainly due to the fact that many areas will no more will be suitable for the species, so they will never come back in that former historical range completely. Okay, so that's a way how the future projections of climate niche could also contribute to the green status assessment and evaluation. And you should consider that for the green status, the assessment go through a slight different approach, as you have to do the assessment for each spatial unit in which you decide to divide the range. So for example, for the Eurasian otter, we did the assessment for 56 different countries falling within the range of the species. So, and the final score is an average of this single spatial evaluation, which is a slight different from the red list assessment. So, and now what we can do. So mitigation include what we can do to all the efforts to reduce the emissions of greenhouse gases that are causing the global warming and the changes in the climate, but also how to cope. This is the adaptation portion that cannot, with climate change that cannot be avoided. So as to mitigation, as many of you know, there have been many conferences of the parties, and the main agreement which was signed in 2015 at COP21 is called the Paris Agreement, which was signed by 173 countries, and where all the countries committed themselves to keep the global warming below 2 degrees centigrade, and pursue efforts to limit warming to 1.5 degrees. You have to consider that we are not talking only of impact of climate change on species or biodiversity. In this case, we are talking about the impact on the whole human populations. So, and this was part of the United Nations Framework Convention on Climate Change. But as you see, just on the 22nd of November, ended the Baku conference of the parties, the 29th in Baku in Azerbaijan, and this was called the finance COP. So because the main goal was to sign an agreement for developed countries to support developing countries to cutting greenhouse gases emissions and deal with the worsening impacts of climate change that is recognized as being mainly caused by the developed countries. So the final agreement was to invest $300 billion a year on this matter, but the developing countries were asking of an investment of 1,200 billion a year. So this conference was considered partly a failure, and some of the developing countries left the conference as a protest, you say, to the complaining. But how is IUCN limiting climate change impacts on nature? So IUCN is providing many different documents and guidelines, for example, for accelerate and just and equitable transition to clean energy and renewable energy sources, but also to promote nature-based solutions for mitigating carbon emissions by 2030. And this involve many different habitat and biomes and human activities, for example, agricultural practice, and you can explore. There is plenty of documents on this but we also need on the websites of the IUCN, but we also need money. So best practice, IUCN committed to support best practices in climate investments and mobilize enhanced finance to enable the implementation of nature-based solutions. And the IUCN estimated that 11 trillion of dollars are needed to be invested in different areas of climate best practices by 2050. So it's a huge investment. In our small area of otters, for example, we suggested that we could design protected areas for otters according to the future species shift. This will increase the protected area coverage in areas that we forecast will be occupied by otters in the future, but also establish ecological networks across national boundaries to adapt to the shift in future suitable climate zone. So and now we are on the last point. Aiuto. What we need to know. We need to know how, for example, extreme climate events will impact, are impacting otters, not only in terms of climatic niche adaptation or shifting, but in terms of impact of these events. We know, for example, that these extreme events are increasing in frequency, both floodings and droughts that have different impact. Floodings will get rid of all calves in the dens, because the dens are provided in the narrow vegetation belts along the rivers, and droughts are will reduce the availability of feeding resources, that affecting the reproductive rates of females. We did models this, we did models this impact of extreme events, for example, in a population viability analysis. And when we included for the small Italian population, which is one of the most endangered otter population in Europe and highly isolated too, when we included the impact of these extreme events and accidental deaths due to roadkills, we had a forecasting trend of the population that will likely become extinct in 200 years. These, we are talking about numbers, but also there are new threats that, for example, Carolina, I don't know if she's here now, but she was very kind. She sent me these slides she prepared, how wildfires are increasing in frequencies, and they are affecting the area. This is Pantanal is losing water surface, but also there are some evidence that since most fires occur during the breeding season of the species, this has already increased offspring mortality and had impacts on the reproductive rates of females. So we still don't know, and we need to have more information and modeling, for example, on marine otters, because nothing has been done, very few has been done, and we don't know which will be the impact. For example, we know that the killer whale is expanding its range and is predating more and more sea otters because of this shifting in the range, but we need some evidence to produce successful strategies. We don't know, and we have to study the impacts of those, for example, new renewable energy source like the mini hydroelectric power stations that are planned about 10, 12, 13 in one river basins. We don't know the impact on otters of this, and we need someone that is going to study the situation before, during, after the setting of this impact. Wow, sorry, maybe too long, but thank you.
Great, thank you so much, Anna. I'm sure on behalf of everyone, I really, really enjoyed that talk. It was really, really interesting. So please continue to put any questions that you have in the chat, and I will share some of the questions that we got during your talk. So the first one from Gerard Smith is, Dear Anna, can you explain why the Lutra is not too much affected by climate change?
Sorry, why the?
The Lutra, so the Eurasian otter, why it's not too affected by climate change?
It's not too affected, first because the exposure components will be all positive. This means that the Eurasian otter will increase the area available, the suitable area to live, because it can expand northwards. So the net balance between the current range and the future range is in favor of an extension of the range. This is one reason. And in the meanwhile, this positive effect is little counterbalanced by the niche sensitivity and marginality. This means, but this is also related to the fact that the Eurasian otter has the widest range among the otters. So it is highly adaptable. Otherwise, it could not live from Japan to Portugal to North Africa. And this is maybe why it will not be so impacted by the climate change as other species.
Great, thank you. We have another question from Ramesh Kathariya. Sorry if I've mispronounced your name there. So with your results, particularly GVI, can we say most of the otters are more threatened by things other than climate change?
Yes, I think we have to really seriously account for the impact of climate change of all the species in the next assessment, red list assessment, for example, global scale that will start in 2026. As yes, I expect that this will lead to the different evaluation of the risk of extinction. This is true for, I'm quite sure for some African species, but we need to rerun the model. So I encourage all of you, and in the guidelines they are giving all the information to run the models, how to get the data, how to clean the data, which model you can use, how you can overlap the models, and all the information are there. So and we have to rerun again, because the time frame that is considered for the assessment is different from the ones we considered in that paper. So yes, you are all committed. We are glad to help.
So we have another question, which is, a large part of a current species occurrence is also determined by competition with other otter species. In the modeling of your future species ranges, did you consider changes in competition with other species?
Oh, that's interesting. This is a follow-up of the paper. I did have a slide that was showing where, for example, there was loss of habitat in area predicted to have more species overlapping ranges, but this really need to be explored, since you have to model the species and see how this shifting, for example, in the future range will lead to an extension of the overlap and likely of competition among species. But also be aware that we need evidence of competition. Because we know, for example, in Southeast Asia, we know that species tend to have a realized niche which account for the competition. I mean, they are specialized on different feeding resources, for example, and likely also on different habitats. But this needs to be explored. So, and this is mainly also in Africa, but I think Southeast Asia is a main area of print. So we both have a problem related to the increase of human population. So the human footprint is expected to be really to impact the area, the suitable areas, but and competition could add another factor that, but we need evidence. So the answer is no. We didn't. We just put in the table as we say, okay, be aware that in these, for this species tend to overlap, the range tend to overlap with these other two species, but yes. So thank you.
And I suppose that kind of highlights how much unknown there is even within this modeling. But to end on a slightly, hopefully more positive note, we have a question that is there or are there any signs of hope, or can you share something that keeps you optimistic with regards to otter conservation in the future?
Well, the positive, one positive evidence is you hearing and following this webinar. So we should spread knowledge and identify areas where we need many young researchers to focus on these issues, on these topics. And remember also, and Sarah can witness this. For example, the disease, what we expect to be the impact of disease on otters following the global warming. So also the future threats that could affect these species according to the spreading of new parasites or viruses, or I don't know. So yes, but I think we started. I mean, we are on the way. We know the problem, and when you know the problem, maybe you will find the solution, one solution that will lead to a positive, an inversion, let's say, of the trend. We experienced that in the Eurasian otter, for example, in Europe, has now been downlisted from near threatened to least concern. And this is mainly related to the many and relevant conservation efforts that have been done on this species in 20 years, not only on this species, but the European Union has promoted through the Habitat Directive, for example, to promote the conservation of biodiversity and conservation of habitats, species, the habitat of the species. I think we have to work harder to get data in countries where we don't know much, where we expect the human pressures to be higher in the future, but we have some positive evidence that if we act, we can succeed. The same stands for the giant otters. When the giant otters, they've been working and promoting action plans, actions that really made the difference. So we are here for this. And yes, I'm optimistic by nature. So
great. Brilliant. Well, thank you so much. Before we end, for those who would like to turn your cameras on, we were hoping to take a photo of all our attendees. So we will quickly do that now. And maybe one of the other youth circle could let us know when they are taking it. We'll give everyone another minute or two.
Okay, I have unmuted myself, which is like new. I haven't said anything for the whole webinar. Thank you, Margherita. I'm going to take a picture of you as soon as everybody is, well, I mean, everybody who wants to is there. I can see Anna. I can see all sorts of nice people. Hello, Heidi. I'm going to take a photo in a second. Okay. Is everyone smiling? Are you all happy with the otters? Yay? Okay. Yeah, that's why they don't let me speak. Yeah. Okay, I've taken pictures. We're good. Yay! Thank you.
Great. So we've put a few links in the chat if anyone's interested in learning more about the Otter Youth Circle or would like more information about the Congress coming up in February. Otherwise, another massive thank you to Anna, and thank you everybody for attending. Hopefully we'll see you at our next webinar.
Thank you.
Here
Bye.
we go. Thanks.
So do you want me to stay or I can say bye-bye?
No, stay, Anna, forever.
Hey, thank you, Anna. That was great.
Yeah, that was super, super
Recording
cool.
once again.
To
Yes.
dance, maybe.